If there's one area of agriculture that I feel like I've watched in my career go from seemingly dull and uninteresting to one of the most talked about aspects of our entire industry, it's soil science.
In recent years, though, soil science has undergone a revolution. Our understanding of soils is orders of magnitude better than it was just decades ago.
That's Dr. Matt Wallenstein. He leads a very impressive soil science team that Syngenta has assembled just over the past couple of years. And while he's passionate about soil health, some of his perspectives might surprise you.
Soil carbon is an imperative for planetary health and for mitigating climate change, but it's a distraction for farmers.
So why is this large multinational agribusiness investing so heavily in soil science? And why now?
We've revolutionized our understanding of how soils are formed and how they function, but we're only at the tip of the iceberg in translating that scientific revolution into solutions for growers.
We're talking soil science and soil health with Syngenta Group Chief Soil Scientist Dr. Matt Wallenstein on today's Future of Agriculture podcast. Hello, fellow Ag Nerd. Thank you so much for joining me. My name is Tim Hamrich, and every week you and I get to hear from the founders, farmers, innovators, and investigators shaping the future of the ag industry. Surprised you there with that last one, didn't I? Got to keep you on your toes. Well, I'm really excited for today's episode to bring Dr. Matt Wallenstein onto the show. Matt is the chief soil scientist at the Syngenta Group, where he leads their efforts to, quote, enable farmers around the world to improve their productivity and profitability through science-based innovation through soil health. Part of that team that he has assembled is my good friend and co-host of the Soil Sense podcast, Dr. Abbey Wick, who you've heard on this show in the past. I think she's been on a number of episodes, if I recall, as well as Dr. Jordan Wade, who was a guest on a very fascinating episode of Soil Sense a year or so ago. I'll have to link to that one in the show notes because it's a great one, so you can check that one out. But anyway, Matt is putting together this dream team, in my opinion, of soil scientists, and I had to bring them on the show today to figure out what I can about what they're up to over there. Prior to joining Syngenta in 2022, he was a professor and department head of soil and crop sciences at Colorado State University. His research over there focused on how the soil microbiome interacts with plants and the environment. He also co-founded a startup called Growcentia, which commercialized a phosphorus solubilizing microbial consortia developed in his academic lab and went on to develop other biostimulants as well. Cool connection to that part is that one of Matt's co-founders at Growcentia was actually on the show 5 years ago. Totally did not know Matt at the time, and it's just more of a coincidence than anything else. But if you'd like, that's episode 165 if you want to go check out that deep track there. I haven't gone back and re-listened to it lately, so send me some feedback if you do. Anyway, I'm going to drop into the conversation today when Matt is telling me what attracted him to this position, even though he already had a startup and a thriving career at Colorado State, when he decided to make the leap 2 years ago to Syngenta.
When I saw the job description for chief soil scientist at Syngenta, I don't think I hesitated 30 seconds before I replied to the recruiter, because I recognize this is a once-in-a-lifetime opportunity where you had one of the big, or really one of the best innovation companies in ag focusing on soil science as a strategic priority. That was an opportunity I couldn't pass up. So for me, the opportunity to make a real impact at scale, not just study soils, understand how they're changing, but actually implement solutions for growers across the world and utilize the innovation powerhouse engine that is Syngenta to accelerate innovation and get really science-based, robust solutions out to growers. That was an opportunity I could not pass up. And then also for me, it's just an exciting intellectual journey to understand how a big global corporation like Syngenta, thinks about how to solve complex problems. And there's no problem more complex than soil health.
How do you define soil health? Because I think we could bring 5 different people on here, perhaps 5 different soil scientists, and get different definitions. So when we are talking about soil health today, what's your definition?
That is the million-dollar question, isn't it? There are many definitions out there about soil health. And for me, it's really simple. It's about the attributes of soil that we can manage that have a direct effect on the outcomes that we care about. So let's break that down a little bit. So soils are all different. There's so many diverse types of soils, and you only have to use your eyes to see that as you travel around the world. You'll see soils that are red and black and white and yellow. And that's just the first clue that we have that tells us how chemically, physically, and biologically different those soils are. But those differences, it's kind of like thinking about, human genetics. That's the blueprint that we're given. That's the baseline. It tells us what the potential of that soil is, right? And those attributes are driven by what kind of rocks underlie that soil and the minerals in that soil are derived from. And it has to do with how old the soils are and what types of plants and organisms are in that environment. Those are the soil forming factors. There's nothing we can do about that. That's sort of like our genetics, right? But then there's a lot of attributes of soils that we can affect through our management of those soils. And we do affect. And that's where I focus when I think about soil health. What characteristics of soil are responsive to different management? And then how do we connect those changes in soil to outcomes like yield, like the ability to hold on to water and deliver it to plants, and nutrient use efficiency?
And what about when the outcomes we desire in the short term may in some ways be at odds with the outcomes we desire in the long term, meaning yield this year versus yield to input ratio long term? Intuitively, I would think like the long term is healthier than just getting what you can out of the short term. But I could see with that definition that the outcomes we desire could be at times at odd depending on your time horizon.
More often than not, we essentially know what the best practices are that lead to soil improvement over time. And the challenge really is, how do we enable farmers to adopt those practices? Generally speaking, we kind of know what works, and not everything works everywhere. It has to be context specific. So for me, the focus is, what are the challenges that farmers face in switching to better practices? And how can we, as an innovation company, help farmers overcome those challenges?
Right. And I would imagine soil health has always been in some way part of Syngenta's approach, but it does seem like a very deliberate act now to build this team that you're building for soil health. So maybe help us understand kind of the why now behind Syngenta's interest in soil health.
Soils are the foundation of food production and are critical to feeding the world. Full stop. But soil science had always kind of played a secondary role in agricultural technology, especially over the modern era, where we focused on the improvements we could make through crop genetics and through crop protection and fertilizer. In recent years, though, soil science has undergone a revolution. Our understanding of soils is orders of magnitude better than it was just decades ago. And that's been enabled by new technologies like DNA sequencing that allowed us to understand the microbiome in soils. So partly it's driven by really rapid advances in soil science that have given us a much better understanding of how soils work. And then, we're really just at the cusp of tapping into that understanding to develop new solutions. From my perspective, soils are the next frontier for agricultural innovation. If we think about it, we've made these tremendous strides in agricultural productivity and sustainability because of crop breeding, because of crop protection, because of fertilizer, but we haven't even scratched the surface of what we can do to increase productivity and sustainability and profitability by helping farmers to manage their soils in a way that improves them over time.
And so what exactly is the charge of your team then? And maybe you could talk a little bit about the type of team that you're assembling within Syngenta.
One of the things that that I'm trying to do is build soil science as a core competency within Syngenta, really to the same level as chemistry or crop genetics. And that's kind of scary to me because those core competencies were built up over decades, if not centuries. I mean, it's really an incredible legacy and, intimidating to think about. But that's the level of ambition that we have. We want to bring soil science integrated into the company, touching all parts of the company so that we can really harness the power of soils to increase productivity. So my team, I brought in the dream team. And I think some of them, Abbey Wick, who co-hosts one of your other podcasts, and I think you've interviewed Jordan Wade. So I was really fortunate that I was able to attract these really talented and exceptional soil scientists that are focused on growers and understand the challenges that growers face and have that desire to work together as a true team to help develop, solutions, develop insights, and really translate soil science into solutions, but also engage with growers. We learn as much from farmers as they could ever learn from us.
And how does that look from an internal perspective with Syngenta, as much as you can share, I guess, of like, all right, we are investing in this dream team of soil scientists, and we want to make, soil science part of our DNA just as much as these other sciences that we've been focused on for years and years and years. How do you track to see if that's working and if you're getting a return on that investment?
One of the big challenges is that soil science really sits at the nexus of everything that we do as a company. It touches crop genetics. It impacts how those genetics are expressed and how that translates into crop performance. It impacts how crop protection works, right? And how it degrades in soils when it reaches the soil. It impacts everything we do, and certainly digital as well, right? A lot of the potential of digital ag is in harnessing soil intelligence, soil information. So the cool thing about my job, but also the big challenge, is having to work with all those different business units, all those different components of our R&D enterprise, and bring them together, really, changing the mindset and thinking about soils as the nexus between all of those other components of agricultural technology. So my group kind of sits within our Syngenta Group, kind of the umbrella organization, so that I can collaborate and build connections between all those different units. But I'm also deeply embedded within the research and development enterprise of the company, particularly within crop protection.
And could you share maybe some examples, even if theoretical examples of outcomes that might be possible, if this initiative is successful, when we really start integrating soil with digital, with chemistry, with, the foundations of soil science, what impact might be possible?
I think soils are going to be the biggest unlock for improvements in yield and in profitability and efficiency. We're already seeing some products come to market, particularly through our biologicals unit, that can directly enhance soil functioning and deliver benefits that are additive to what we can already do. That's just the tip of the iceberg. As you say, I think the real potential is when we can start thinking about soils as the nexus within the agricultural system and harnessing the information that we can gain by mapping soils and understanding the variability across a field, never mind across the world, to help farmers, do better product placement, and not just the traditional decisions that are driven by soil information, i.e. fertility, right? But we can go beyond fertility and start informing, seeding rates. We can inform the timing of, applications. We can inform the rates of things like herbicides, fungicides, so that every dollar spent on the farm goes that much further, and that we don't waste anything, that we only put the right product at the right time and the right amount where it's needed, because soils are a big driver. And right now we don't incorporate any information about soils into most of the decisions that a farmer makes across the season.
And with that, Syngenta has a long history of working with farmers. Does incorporating this knowledge of soil science into operations does it change at all the approach? I mean, if I'm a farmer and I've always kind of worked with Syngenta a certain way, are they going to start providing me with different products, different advice as a result of this initiative, in your opinion?
Today, we already offer a soil scanning service in Europe. And, I consider that one of our first forays into helping farmers to see what's currently invisible beneath their feet, right? To understand that variability in soil so they can make better decisions. In other places, including Latin America and China, we have direct retail outlets that provide agronomic advice, in some cases offer soil testing, again, to help farmers make better decisions. So that's where we are today. Now, going forward, I think it all depends on whether or not we can demonstrate value to the customer, right? If we can demonstrate that we have unique insights that add value beyond what they can already see in their soils, and they already know about their soils through their deep experience, and help them achieve better outcomes, then I think we have a win-win and likely, a driver of business growth.
You'll hear a common rhetoric out there, which is the massive gains that we've seen in agriculture, specifically, in the developed world, have come at the expense of soil health. And number one, I guess, is I don't know to what degree you subscribe to that thinking, but the follow-up question is, assuming that you do agree with that, what gives you hope that we can have our cake and eat it too, that we can improve our soil health, but continue the productivity gains that we're used to seeing?
The development of agriculture, without doubt, has had an impact on soils. We've lost a lot of soil organic matter, soil carbon, and much of that, though, came from the original conversion of native forest or grasslands into agriculture, right? It was when that plow went across that field, it turned over the soil and made it vulnerable to erosion and vulnerable to microbial breakdown of that organic matter. The good news is, though, we are already so much more sustainable, and our practices that we have today, especially in more developed areas, are orders of magnitude better for soils than some of those earlier practices. So on average, agriculture is already good and getting better. It's not bad and getting worse. Now, that's not to say that agriculture doesn't have a big impact on soils. We have to drive innovation and accelerate innovation so that we get better. We've got to stop erosion. I mean, erosion is a loss to the landholder, to the farmer, and it's bad for the planet, right? That's the first thing. Let's stop the bleeding. But then we can think about, as we go beyond that, how do we actually regenerate soils and improve soil health over time? And that's a win-win for the planet. It's a win-win for the farmer. Everyone benefits if we can help farmers adopt the practices that enable those soils to improve over time.
And you've said you still look at soils as a frontier, even though we've seen these massive discoveries in soil science and breakthroughs. I think you call it kind of a revolution in the field in recent years. You still view it as a frontier. Why do you still see it as a frontier?
We've revolutionized our understanding of how soils are formed and how they function, but we're only at the tip of the iceberg in translating that scientific revolution into solutions for growers. I think right now, we don't even really understand or see the opportunity in front of us because soils are, beneath our feet. They're below ground. And what we're increasingly seeing as we apply new sensors and new analytical approaches is we can map the gap between where a farmer is today, where their soils are today, and where they could be. And we can calculate the improvement that they might see in yield, in water use efficiency, in yield consistency in the face of weather intensification. And we can help them to see the opportunity they have and what would be gained by managing their fields in a way that improves the soil over time.
And does it feel like we have the tools we need to sort of map that gap and bridge that gap? Or are there any soil related tools that you're kind of still hoping can advance to the point where it better enables farmers to build healthier soil?
Let's talk about soil intelligence. So today, the standard is, to go out in your field and collect a soil sample, maybe, one sample or a composite sample that represents, many acres, and maybe do that every 5 years, send it to a lab, and we get back, some data mainly around the fertility of the soil, but also the pH, the soil organic matter. That's helpful information. But boy, that's like, seeing the world through a really narrow lens, right? There's so much more out there. And why don't we have that information? Because A, it's really expensive. Even that limited soil sampling that happens today requires someone to go out in the field, or you have to ship the soils to a lab. It's expensive, right? There are already new sensors and scanning technologies that are bringing down the cost of accessing that information about soils. And, like any other technology, I think that we're going to see tremendous leaps in the next year. Not only that, but we have new approaches that allow us to fuse together different types of data. So we can take that limited soil sampling and we can add on a soil scanning layer or satellite data. And together, it's really powerful. When we start adding those layers together, we can now, at a relatively low cost and getting lower, get really meaningful information about how those soils vary over time and space, and start to translate that into helping farmers make better decisions and therefore get better outcomes.
And when it comes to soil biology, I mean, are we still at the point where the only way to kind of have a sense of the biology in your soil is to send it to a lab and have somebody physically look in a microscope to see like what nematodes are in there? Or, I mean, I know we've got the DNA sequencing, but it still seems pretty labor intensive. It seems like that's a massive frontier as well.
It is. And, when I was focused on science research, that was a large area of focus for me. So using those DNA-based technologies to understand the incredibly complex microbiome that is the soil microbiome. You're holding a handful of soil, and it may have tens of thousands of different types of bacteria and viruses and archaea and fungi. I mean, that's humbling, right? It's like holding a rainforest in your hand. We have those technologies today, and they are commercially available. And even though the cost of sequencing has gone down, it's like Moore's law. Even though the cost has gone down, it's still pretty expensive. It's really cool data, right? You get back this really rich data set of what's in your soil. But we're in the early days of translating that into helping farmers make better decisions, right? And that's, from my perspective, it's not the access to information about soil biology, it's being able to translate that into a decision, right? That's the current challenge that we're facing. And, there's lots of startup companies that are working on that problem and making good progress. But I think that we're still in the early days of that technology.
Well, I know you've worked with farmers for a long time. In this role, I imagine you've been able to have more international experiences with farmers. Is there anything you've learned about soil health and adopting soil health, principles on the farm from other countries that maybe those of us listening in the U.S. might find, interesting?
I've had the opportunity to work with some of the largest and most successful farmers in the world in this job. And I've been so impressed by the sophistication at which they manage their soils. And let me give you an example. So one of the farmers we work with in Argentina, which is a place where these practices like no-till have been widely adopted for many decades, those farmers have developed such sophisticated approaches that I was blown away. So for example, this one group we work with, they have a full menu of cover crop prescriptions to address specific soil challenges. So for example, for compaction, they may have 3 or 4 different cover crop options, and their main purpose is to break up that soil compaction at different depths. And it's like it's precision cover cropping, right? I mean, there's incredible experience and expertise developed by farmers, and those farmers are happy to share with others. There's such a rich diversity of experience and creativity and ingenuity out there. And, there's this great opportunity to tap into that.
So they like variable rate seeding their cover crop? I mean, not only choosing which species, but also what rate and everything based on conditions?
Yeah, and they're thinking in multi-year rotations. So they map out, multi-years of which cover crops they're going to use in which sequence, and it's really purpose driven. They're doing it not just, to do cover crops, but for really more specific purposes like breaking up compaction or addressing salinity. So they see cover crops as one of the tools in their toolbox.
Well, someone who is more cynical than I might say, this is just Syngenta trying to position themselves as sustainable, right? It's kind of a marketing PR thing where, see, we're sustainable, we care about soil health, we have this team. Obviously, you don't feel that way. You're a scientist. You want to see real impact being made. But I'm curious, how do you speak to that level of skepticism?
Yeah, I totally understand that skepticism from people that don't understand the agricultural industry and particularly innovation. I'm really an environmentalist. I care about the environment. I want to help solve climate change. And I believe that the way that we help solve climate change and reduce the environmental impact of agriculture is by putting the best technologies and the best scientific knowledge into the hands of the growers that are out there every day making decisions about how to manage their fields. So I'm very clear that innovation and technology is critical to enabling sustainable agriculture.
But yet, you haven't once mentioned carbon sequestration. Is that deliberate in that you think that the answer is more related to reducing emissions than you do sequestering carbon, or is that just a topic we just haven't stumbled upon yet?
Soil carbon is an imperative for planetary health and for mitigating climate change, but it's a distraction for farmers. Let me explain why I say that. So let's think about soil carbon for a second. There's no doubt. Look, soil carbon is one of the biggest reservoirs of carbon on the terrestrial Earth. There's more carbon in soils than there is in all the atmosphere and plants combined. We also know that we have lost a lot of carbon from soils, about 120 gigatons through the history of agriculture. That tells us that there's a big capacity in soils to store away more carbon than is currently in there. That's great. How are we going to do that? So every year in every field, whether a soil gains or loses carbon is determined by two things: the balance between how much carbon goes into the soil and how much carbon goes out. How much carbon goes into a soil is driven by plant photosynthesis, which is also yield, right? So anything that we can do to increase plant productivity and yield across a whole year, which might include cover crops or crop intensification, that means more carbon is going into the soil. And the more of that plant material we can keep on the field, so residue retention, that means more of that carbon is going into the soil. So those are good things. Let's enable that. How do we reduce the amount of carbon that's being lost from a soil? We minimize soil disturbance. So things like no-till are going to help prevent acceleration of soil carbon loss from soils. So let's focus on what we can do to help farmers adopt the practices that enable more carbon to stay in the soil on an annual basis, right? Let's enable those regenerative ag practices. Also, soil carbon can be a distraction because the low-hanging fruit is to reduce greenhouse gas emissions from agriculture, which are substantial. Agriculture, including transportation, is about a third of our global emissions, and it's going to become an increasingly large part of that emissions pie as other sectors like transportation and energy decarbonize. So we have an important job to do. Let's focus on the low-hanging fruit first of reducing those greenhouse gas emissions, which include emissions that come directly from soils. Most of that is nitrous oxide that comes from low nitrogen use efficiency. That's bad for the farmer because they're seeing the money they invested in that fertilizer, go up in smoke, go up into the air. Nitrous oxide is 300 times more powerful than carbon dioxide as a greenhouse gas. So I think there's a couple of things I would focus on. First of all, what can we do to increase nitrogen use efficiency and reduce greenhouse gas emissions from soils? Again, it goes back to enabling best practices. And, when it comes to soil carbon, again, it's critically important, but the reality is soil carbon accumulates slowly over time. It's not a rapid process. And the amount that we can sequester in soils is relatively small relative to the amount of greenhouse gases that come out of the soils into the atmosphere. So both are important, but I also think it can be a distraction to spend our energy and time counting beans, measuring soil carbon, which is difficult because it changes so slowly on a relative basis. It's hard to measure those changes over time. So my theory of change is this. Let's help farmers across the world adopt regenerative agricultural practices like no-till that on average across the world are going to result in a new era where instead of losing carbon over time, that we're gaining soil carbon over time by enabling those practices. That's a really good thing. But I think our energy should be spent on delivering innovation to farmers so they can adopt best practices rather than on counting the amount of carbon that's in soils.
Well, I really appreciate that. That was very clear and succinct way to tackle a very nuanced topic. If I can get you to play a little bit of a hypothetical game here, one thing I always hear is that we need more funding to invest in regenerative agriculture. And if I'm being honest, I don't know what that means. You know, for you, if Syngenta were to come and say, look, Matt, we want to give you a large sum of money, let's say, $100 million, how would you go about investing that in regenerative agriculture?
Yeah, you touch on an important topic. Regenerative agriculture is it's a buzzword and you hear it in different contexts. And we need to be a lot more specific, right? Let's get down to something that's really meaningful for farmers, right? Let's talk about implementing conservation tillage, or no tillage. Let's talk about where it makes sense, adding in cover crops or diversifying the diversity of crops in the rotation. It's not that complicated, but it's really hard, right? I mean, that's easier said than done. And so the way I would approach it as a scientist is I would say, all right, well, where are we today? Where do we want to go? So, okay, the science suggests that, on average, where it makes sense, when we adopt these practices, it leads to better outcomes. It leads to higher yields. In some cases, 10% higher yields within not that long of a time frame. So, it's exciting. But why isn't every farmer adopting it now? It's hard. And we don't have the years of experience. So asking a farmer to take that risk of changing practices is a really big ask. So let's de-risk that for growers. But also there's lots of technical challenges, right? Like, can you access your field at the right times to be able to actually do a good job getting those cover crops to germinate and to come up and be productive? It's got to make sense to the grower or else they're not going to do it. I mean, that's it. So I'd put that investment into understanding the problem, really understanding, what's preventing farmers from adopting those practices today, and B, solving that challenge, right? And some of that's going to be technical. So developing products and testing in them within the context of those practices so that we can give farmers confidence that we're going to help them through that journey. And on the other side of that journey, and it may be a few years before they see this, but they're going to be more productive, more profitable, more sustainable. Right. And that's good for them. That's good for businesses that want to sell products to growers. It's good for everyone. So let's tackle the problem, at the ground level and just be practical and try to solve those specific challenges.
Well, you were an entrepreneur in the biological space before we had the, quite as many companies trying to do that as we do today. Give us your take on the current biologicals market and where that might fit into this broader conversation about reducing greenhouse gas emissions and improving soil health and kind of creating a better planet. How do you see that landscape today?
It's been exciting to see the biologicals market develop and mature from the era of snake oil into real science-backed solutions. But there's still a long way to go, right? And let's break down that category of biologicals. I think you've done this on other episodes into meaningful categories. So biocontrols, biostimulants, nutrient use efficiency products. I get particularly excited about nutrient use efficiency products because, again, nutrient use efficiency is a big problem, right? When farmers add nitrogen to their soils, less than half of it on average ends up in the crop. I mean, that's tragic. That's a waste, and it has a big environmental impact. Let's solve that problem. Biologicals are going to be a big part of that. Biostimulants are also exciting because they can help plants mitigate abiotic stresses like drought stress or heat stress. And again, that's an additive value. In many cases, that's not something you can get from chemistry. So biologicals have and will have an important place. It's another tool in the toolbox, right? And we need to give farmers all the tools that we can and all the science-backed tools that have gone through that rigorous development process so that when they buy it, they can buy it with confidence. So I'm excited about the future of biostimulants. I go back to what I said earlier, though. We are just at the beginning of this journey. We are just at the beginning of translating the science of the soil microbiome into solutions. So for many years to come, we're going to see more effective solutions, and we're going to be able to do better product placement using soil intelligence as the basis for being able to predict which products are going to work where.
Matt, this has been great. Where didn't we go that you were hoping to get to today? Is there anything that you either want to add or emphasize before we close out?
I want to emphasize that soil science and soil health is the next frontier for agriculture. It's pretty clear to me that the biggest gains we're going to see in agricultural productivity, sustainability, and profitability are going to come from using information about soils to help farmers do better product placement, better long-term management, and have more effective products that lead to better outcomes. So I think, when we look at the next coming decades where we have big challenges in agriculture, I think the biggest gains are going to be from soil health and from using AI and other digital tools to help farmers really optimize their operations and help feed the world.
And to get there, how much of the challenge of getting there is technical versus interpersonal?
They are so intertwined, I don't think we can separate them, right? You could have great technology, but if you haven't developed that technology with growers and understanding how they make decisions and understanding their operations, it's just going to be a fun experiment, right? So it's about technology, yes, but it's about understanding the people that are out there every day making tough decisions and taking on risk in their operations. By bringing those together and tapping into the power of AI and other tools, there's so much potential to improve agricultural productivity and sustainability that, the future is so bright.
Matt, thank you for this. I wish you the very best of luck. I think, I think highly of you. I think highly of your team, and it'll be exciting to see where all this leads.
Thanks. It's been a pleasure, and really excited to, share our journey as it progresses.
All right. Well, that is going to do it for today's episode. Thank you very much to Matt Wallenstein for being on the show today. I think you probably know where you can go learn more about Syngenta online, of course, their website or on all the social media. I know Matt is active on LinkedIn, so you can find him there. Doing some cool stuff, and I'm really interested to see where this develops, this core competency in soil science and trying to infuse it in such a diverse and dynamic and innovative company like Syngenta. Thanks again to Matt for being on the show. I also use this to plug the Soil Sense podcast. We have taken a little bit of a break. We haven't released any episodes since last fall, but we have some really great content in our library. I'll link to that episode Abby and I did with Jordan Wade, and I think that's probably a good starting place to go check out some other content over there as well. So shout out to the Soil Sense podcast. Of course, that's a bit of a shameless plug, but anyway, thanks so much for listening. I'll be back next week with another story of ag innovation.